Welcome to The Explainer, where we break down big ideas. I mean, it sounds like something straight out of sci-fi, right? But today, we're actually going to look at a revolution in manufacturing that could do just that. We're talking about moving past plastics and into a world where we can literally print with life itself. All right, so to really get into this, let's start with the incredible promise of what's called additive manufacturing, but you probably just know it as 3D printing. See, traditional manufacturing is, well, it's subtractive. You take a big block of something and you carve away what you don't need. 3D printing? It flips that completely on its head. It builds objects from nothing, from the ground up, adding one super precise layer at a time, all from a digital design. The old analogy of building with digital Legos? It's still a perfect way to picture it. And the benefits here are just huge, a total game changer. For one, you can customize pretty much anything and only make it when you need it. You can design parts that are lighter but also stronger, and you cut way, way down on waste. But it also changes where we make things. We're talking about localized manufacturing, making stuff right where it's needed. And what does that mean? A whole lot less shipping, which means a big drop in CO2 emissions. So, this sounds amazing, right? Like the perfect, sustainable answer to all our problems. But there's a catch, and honestly, it's a pretty big one. It's hiding in plain sight, the stuff we're actually printing with. You see, the most common materials are, you guessed it, plastics. You've got your ABS plastic, which comes from petroleum. Sure, you can recycle it, but it's not biodegradable. That stuff is going to stick around for hundreds of years. Then you've got PLA. People love to call it a bioplastic because it's made from cornstarch, but here's the thing. Its green reputation is kind of shaky. It only biodegrades in these really specific industrial composting facilities, and if you try to recycle it, the quality just tanks. So here's the bottom line. For 3D printing to actually deliver on that incredible, sustainable promise we were just talking about, it needs more than just a cool process. It desperately, desperately needs a revolution in its materials. All right, so let's talk about that revolution. Where does the solution come from? Well, you might be surprised. It comes from nature's own toolkit. This is where we get into something called 3D bioprinting. It's this pioneering new field, and one of its star players is something called mycelium. If you've ever seen the intricate, almost web-like root structure of mushrooms, that's mycelium. And how this works is just fascinating. You're not just printing an object, you're growing it. The printer starts by laying down a base of, get this, soil waste. Then it precisely prints a structure using living mycelium, which basically acts like a natural, self-growing superglue. After that, you just pop the whole thing in an incubator, and that mycelium network grows and weaves everything together, making the final object super strong. Okay, so that's already incredible, right? Turning waste into something useful. But what if we could take it a step further? I mean, what if we could go beyond just zero waste and actually turn the act of manufacturing into a tool to fight climate change? And that's where we get this idea of carbon negative manufacturing. Now, this isn't about being carbon neutral. No, this is way beyond that. This is a process where making something, anything, actually cleans our air. It pulls more carbon dioxide out of the atmosphere than it emits. Just think about that. So what's the magic ingredient here? It's a biopolymer made from algae. Yeah, that's right. The green stuff you see in ponds and in the ocean, that's the key. And this is where the mind-blowing part comes in. As algae grows, what does it do? It breathes in massive amounts of CO2. It's just what it does. So, when we harvest that algae and turn it into a material for 3D printing, we're basically taking all that carbon it captured and locking it right into the final product. Imagine it. Your chair, the packaging for your food, even your phone case, they could all become little carbon storage devices. So, when you put all these pieces together, this smart printing, the living materials, the carbon negative process, what do you get? Well, you get the foundation for something called the circular smart factory. And look, this isn't just about swapping out plastic for algae in the same old factory. No, this is a whole new way of thinking about industry. It's a model where you combine advanced tech like 3D printing with these amazing, natural, carbon-sucking materials to build a system that's sustainable from the ground up. So think about how this changes everything. In a factory like this, you stop making tons of stuff you just hope someone will buy. Warehouses full of physical inventory? Nope. That gets replaced by digital data, designs that are ready to print the second you need them. And production happens right there, locally, close to whoever is buying it. That makes our supply chains way shorter and a lot tougher. And, of course, if you're not shipping things all over the planet, you're slashing those CO2 emissions from transport. It's just a smarter, leaner, and way cleaner way to make, well, everything. So, really, this isn't just about swapping materials. This fusion of tech and biology fundamentally changes the entire game. It's about shifting manufacturing from being a huge part of the climate problem to being a powerful part of the solution. So, the big question we're left with isn't just what can we make anymore, it's what can we grow? What can we cultivate and create when we finally start working with nature instead of against it?